Welcome to the shadowy world of wakefulness. Did you know that, after just 24 hours without sleep, your cognitive impairment equals that of someone with a blood alcohol level of 0.10%, legally drunk in most countries? Welcome to Lecture 146 of our Unusual Science series, where today we'll journey into the mysterious realm of sleep deprivation, experiments, scientific ventures into the twilight zone of human consciousness. Sleep, that enigmatic state we spend roughly one-third of our lives in, remains one of neuroscience's most baffling frontiers. Yet throughout history, researchers have been captivated by a perplexing question. What happens when humans are deliberately kept from this essential state? The answers, as we'll discover, are both fascinating and disturbing. The record breakers. Pushing human LIMITS, the most famous sleep deprivation experiment, began in December 1963, when a 17-year-old high school student named Randy Gardner embarked on a science fair project that would become legendary. Under the supervision of Stanford sleep researcher Dr. William Dement, Gardner remained awake for an astonishing 11 days and 25 minutes, 264 hours of continuous consciousness. The effects were profound and escalated in a haunting progression. By day 3, Gardner struggled to focus his eyes and experienced his first bout of nausea. By day 4, his thinking had become noticeably fragmented. As the days wore on, his speech slurred, memory faltered, and paranoia crept in. By the final days, he began experiencing microsleeps, brief seconds, where the brain essentially forces itself into unconsciousness while the eyes remain open, and reported terrifying hallucinations. Yet remarkably, after sleeping for 14 hours following his ordeal, Gardner appeared to fully recover with no lasting effects. Before Gardner, radio DJ Peter Tripp captured public attention in 1959 with his Wakeathon broadcasting for 201 hours straight from a glass booth in Times Square. Unlike Gardner, Tripp's experience took a more sinister turn. By the third day, he had developed severe hallucinations, believing his shoes were filled with cobwebs and that a drawer was on fire. More disturbingly, he became convinced that researchers were imposters trying to kill him. Tripp eventually recovered, but colleagues reported his personality was permanently altered after the experiment. Behind the Iron Curtain. The Russian experiments, perhaps the most enigmatic sleep deprivation research, allegedly occurred in the Soviet Union during the 1940s. According to accounts that remain difficult to verify, Russian researchers used experimental stimulants to keep political prisoners awake for up to 15 days. The reports describe horrifying consequences: subjects tearing at their own flesh, experiencing psychosis, and ultimately suffering complete physical breakdown. While these accounts may be exaggerated or apocryphal, they highlight an important ethical dimension. Sleep deprivation has been used as a form of torture throughout history and continues to raise profound moral questions about experimental boundaries. The physiology of deprivation. Body in rebellion: what happens to our physical form when sleep becomes impossible? The cascade of physiological changes is both extensive and alarming. After just 24 hours, your metabolism begins to dysregulate. Glucose processing becomes impaired, mimicking a prediabetic state. Your immune system activates inflammatory responses, believing the body is under attack. Hormone production becomes chaotic, cortisol rises, while leptin and ghrelin, your hunger hormones, fall out of balance. By 48 hours, your body temperature begins to fluctuate abnormally. Your heart may develop subtle rhythm changes. Most tellingly, your brain begins to operate differently. EEG readings show altered wave patterns, particularly in the prefrontal cortex, the region responsible for higher cognitive functions. Beyond 72 hours, the truly bizarre begins. Your perception distorts as your brain struggles to process sensory information. The line between waking and dreaming blurs. Your eyes remain open, but parts of your brain actually fall asleep in a phenomenon called local sleep. Neural networks temporarily going offline while others remain active. The mind unraveled. Psychological EFFECTS, the psychological journey of sleep deprivation, is equally captivating and disturbing. Initially, you may experience mood swings and irritability, common experiences during a late night. But as deprivation continues, these effects intensify dramatically. After 48 hours, emotional regulation becomes severely compromised. Subjects report heightened anxiety, impulsivity, and profound cognitive tunneling, the inability to think beyond immediate concerns. Decision-making abilities deteriorate, with subjects showing impairments similar to those observed in patients with frontal lobe damage. Most intriguing are the perceptual distortions that emerge beyond 72 hours. These aren't mere hallucinations, but something more profound, a fundamental unmooring of consciousness. Time perception warps. Colors may seem unusually vibrant or dull. Ordinary objects appear to breathe or pulse. The boundary between self and environment becomes uncertain. In the most extreme cases, subjects can develop symptoms nearly indistinguishable from acute psychosis, paranoid delusions, disorganized thinking, and sensory hallucinations. Yet unlike true psychosis, these symptoms rapidly reverse once sleep is permitted. Modern methodologis. Ethical boundaries, given the psychological distress observed in total sleep deprivation, modern sleep research has evolved toward more ethical approaches. Today's studies typically employ partial sleep deprivation protocols, where subjects sleep 4 to 5 hours nightly rather than none at all. Researchers use sophisticated monitoring technologies, actigraphy wristbands, portable EEG headsets, and cognitive testing batteries to detect subtle changes in brain function and behavior. The military has maintained particular interest in this research, seeking to understand performance limits during extended operations. The U.S. Army Research Institute has conducted numerous studies on cognitive performance during sleep restriction, finding that certain cognitive functions decline linearly with sleep loss, while others show threshold effects, remaining stable until suddenly deteriorating after a critical point. Perhaps most fascinatingly, researchers now distinguish between acute and chronic sleep deprivation, finding that the brain adapts differently to each condition, with distinct neural mechanisms and compensatory strategies. The resilience enigma. Why some endure one of the most perplexing discoveries in modern sleep research is the remarkable variation in individual responses to sleep deprivation. While most people show severe impairment after 24 hours awake, approximately 10 to 15% of the population demonstrates unusual resilience, maintaining near-normal cognitive function even after extended wakefulness. Genetic research has identified specific polymorphisms associated with this resilience, particularly in genes regulating adenosine, the neurotransmitter that builds sleep pressure during wakefulness. One variant, in the COMT gene, appears to enhance the brain's ability to maintain prefrontal cortex function despite sleep loss. Intriguingly, those with naturally higher baseline working memory capacity and cognitive flexibility tend to withstand sleep deprivation better, suggesting some underlying neural architecture may provide protection against the effects of extended wakefulness. The fatal insomnia connection, the rarest and most tragic insight into sleep deprivation, comes from a condition so uncommon that fewer than 40 families worldwide have been diagnosed with it. Fatal familial insomnia. This genetic prion disease progressively destroys the thalamus, eventually rendering sleep impossible. The progression of symptoms in FFI patients mirrors experimental sleep deprivation with horrifying precision, cognitive decline, hallucinations, autonomic dysregulation, but continues relentlessly until death occurs, typically within 12 to 18 months of symptom onset. The existence of this condition underscores sleep's absolute necessity for human survival and provides a sobering perspective on the ethical boundaries of experimental sleep deprivation. Conclusion: the necessity of darkness as we emerge from our exploration of sleep deprivation's shadowy landscape, several truths become clear. Sleep is not merely a passive state, but an active, essential process that maintains our physiological and psychological integrity. When we deprive ourselves of sleep, we don't simply become tired. We begin to fundamentally unravel at both cognitive and cellular levels. The experiments we've discussed reveal the extraordinary resilience of the human body and mind, capable of functioning, albeit impaired, for days without rest. Yet they also illuminate the absolute necessity of sleep and the profound ethical questions surrounding its experimental manipulation. As you rest your head on your pillow tonight, remember, in that mysterious darkness, your brain performs some of its most essential work that no amount of wakefulness, willpower, or stimulation can replace. Until next time, sweet dreams.